Good morning friends. Last lecture we have to discuss about the soft chemistry route, that is about the sol gel synthesis. Okay, in this lecture we have to discuss the next soft chemistry route, that is about the electrochemical method. Okay, this electrochemical method, therefore the vanadate spinel of the formula MV2O4 as well as the tungsten bronzes A5WO3, it have been prepared by the electrochemical route. Means that vanadate spinel of the formula, it will be tungsten bronzes A5WO3, it have been prepared by electrochemical route. Means that this electrochemical route, it is a prepared the vanadate spinel, it is a prepared the vanadate spiral. Okay, vanadate spinel, it is a prepared by the electrochemical route. Okay, secondly, when the current is passed through two inert electrode, okay, when the current is passed to the two inert electron and it is immersed in molten solution of the alkali metal tungstate, that is A2WO4 and the WO3, that is the oxygen are liberated at the anode. Okay, look at this. When the current it is passes through the two electrode, current it is passes through this two electrode. Okay, this is the reference electrode, and secondly it is a platinum wires electrode. Okay, this is the two electrode, therefore your current it is passing to this two electrode. Okay, then secondly, uh, when current is passes through this inert electrode and it is immersed into the molten solution. Okay, look at this solution are immersed into this molten solution. That solution, it is about the potassium hydroxide. That potassium hydroxide, it is a molten solution of the alkali metal. Okay, you have to know about the potassium, it is a alkali metal tungstate. Okay, and there's A2OW44 and WO3, therefore the oxygen is liberated at the anode. Okay, in this KO solution, therefore your oxygen it is liberated at the anode. Means it is a left side electrode, it is a oxygen left side electrode, therefore the oxygen are liberated from the left side anode electrode. Okay, then secondly, the oxides containing the metal in high oxidation state are conveniently prepared the electrochemically. Okay, therefore the different types of the oxides we have to containing the metal in the high oxidation state, and that is prepared the electrochemically. Means therefore your electrochemically it is a prepared the oxide containing metal in high oxidation state. Okay, so this is also the electrochemical method. Nextly, the thin films of the BaTiO3 and the lead zirconate titanate, it have been prepared by cathodic reduction. Means that cathodic reduction you have to prepare the thin films such as the BaTiO3 and the lead zirconate titanate, it is prepared by this cathodic reduction. Okay, look at this diagram. That diagram, it is says that is a schematic representation of the electrochemical cell and the rotating disc electrode. Okay, this is the first A part. Okay, look at this B part. B part, it is a pellet. Okay, that pellet, it is containing the electrical contact and the silicon rubbers. The silicon rubber, it is a covering of the electrical contact or the pellet. Okay, and then first A part, it is shows the electrochemical cell. Okay, look at this beaker like shapes, and therefore it is a electrochemical shells, and the B is a rotating disc electrode, that it shows the electrical contact, silicon rubber and the pellet. And this is the schematic representation of this electrochemical method. Okay, nextly, the electrosynthesis of the crystalline rare earth chromate of the formula is about the Ln2Cr3O12 7s2, that is a Ln is equal to lanthanum, pronuncium and the neodymium. Means this is the rare earth chromate. Okay, and therefore your electrosynthesis of the crystalline rare earth chromate of the formula, means we have to synthesize the crystalline rare earth by the electrosynthesis, and therefore it is why its formula is about Ln2Cr3O12 7s2, and therefore you have to put up the Ln into the lanthanum, pronuncium and the neodymium. Means this atom you have to put up in the Ln. Okay, and therefore it has been carried out by the cathodic reaction of an LnNO3 thrice solution. It is containing K2Cr2O7. Means you have to taken the cathodic reduction, and therefore this cathodic reduction it an LnNO3 solution, and that containing the K2Cr2O7. Okay, therefore the giant magnetosteresterons resistance are also prepared by cathodic reduction of the non-aqueous solution. Okay, that means your giant magnetoresistance it is also prepared by, means this giant magnetoresistance it is also prepared by the cathodic reduction of the non-aqueous solution. Means your cathodic reduction of the non-aqueous solution you have to prepare the giant magnetoresistance. Okay, then the monosulfide of the uranium, gallium, thorium and other metals are obtained from the solution of normal valent metal sulfide and the chloride in the sodium chloride and the potassium chloride, it is as eutectic. Okay, that therefore you have to know about the monosulfide. Okay, that monosulfide of the uranium and the gallium and the thorium, this is the three monosulfide, and that monosulfide it is obtained from a solution of the normal valent metal sulfide. Means normal valent metal sulfide you have to obtain the uranium, gallium and thorium, and the chloride in sodium chloride and potassium chloride are eutectic. Means your chlorine atoms it is in the sodium chloride and the potassium chloride it is as a eutectic. Okay, then secondly the solvent whose decomposition potential are high. Means in this electrochemical method you have to use this solvent, and that solvent which decomposition potential are high, means your solvent's decomposition potential is high. Therefore this is all about the electrochemical method. Okay, then nextly hydrothermal. Okay, so next route is soft chemistry route is hydrothermal. Hydrothermal it is a synthesis, a unique method for crystallizing the substances from high temperature aqueous solution at high vapor pressure, also termed as hydrothermal method. Okay, look at this definition of the hydrothermal. The hydrothermal synthesis it is a unique method for the crystallizing substances. Means therefore you are to crystallizing these substances from the high temperature aqueous solution at high pressure. Means you have to synthesize the method for crystallizing substances, and that substances you are to from high temperature aqueous solution at high vapor pressure, and therefore this term are known as hydrothermal terms. Okay, this term are known as hydrothermal method. Okay, therefore the term of hydrothermal it is a geologic origin. Okay, the term of hydrothermal it is of geological origin. Okay, then third point is it is said that the hydrothermal synthesis it can be defined as the method of synthesis of single crystal that depend on the solubility of minerals in hot water under the high pressure. Okay, then you have to synthesize. Okay, means that hydrothermal synthesis you have to define as the method of synthesis of single crystal. Okay, the method of synthesis of single crystal, and that depend on solubility of the minerals. Means your method of synthesis of the single crystal method, and that is depend on the solubility of the minerals in hot water means in your hot water, therefore the solubility of the minerals, and that is depending upon the synthesis of single crystal. Okay, then secondly the crystal growth is performed in an apparatus, and it is consisting of the steel pressure vessel called as the autoclave. Okay, that autoclave is an important definition. It says that the crystal growth is performed in apparatus consisting of a steel pressure vessel. Okay, means your crystal growthness it is performing in apparatus. Okay, it is performing in apparatus, and that apparatus it is a consisting steel pressure vessel known as autoclave. Autoclave you have to know about the cooker. Okay, that cooker it is also known as a autoclave. Autoclave means what? It is a directly the steam it is passes into the air. Okay, from this autoclave, then in which the nutrient it is supplied along with the water. Okay, the temperature gradient it is a maintained between the opposite ends of the growth chamber. Okay, therefore in this hydrothermal method, therefore the temperature gradient it is a maintained between the opposite end of the growth chamber. Means opposite end of the growth chamber you have to maintain the gradient temperature. Okay, at the hotter end the nutrient solute dissolve, while at the cooler end they deposited on the seed crystal and it is growing the desired crystal. Okay, at hotter end then your nutrient soluble is dissolved, means your hydrothermal methods it's hotter end, and therefore your nutrient solution it is dissolved, and that cooler and it is deposited on the seed crystal, means hotter end nutrient solute is dissolved, and at cooler end it is a deposit into the seed crystal, and that seed crystal it is a growing into the desired crystal. Okay, this is all about the hydrothermal. Look at this diagram of this hydrothermal, such as the washing machine it is also the example, and then the Teflon chamber, then stainless steel chamber. Okay, and that the bursting of the cheese, म्हणजे example like you have to know about the कुल्फीवाला. ओके, कुल्फीवाला काय करतो की याच पद्धतीचं एखादा हायड्रोथर्मल चेंबर घेतो आणि त्याच्या साईडनी एक प्रकारचा आईसनेस प्रोव्हाइड केल्यानंतर एक प्रकारचे कुलिंगनेस फॉर्म होते, त्या कंपार्टमेंटला काय होते, कुलिंगनेस फॉर्म होते. दॅट प्रोसेस इट इज अ हायड्रोथर्मल प्रोसेस. ओके, अँड नेक्स्टली the hydrothermal synthesis means what, ki the reactants are dissolved in water or another solvent in a closed vessel. Okay, means your reactants it is a dissolved in water, reactants are dissolved in water, and now the another solvent it is in closed vessel, means in hydrothermal synthesis you have to take the reactant, and that reactant it is a dissolving water, and another solvent it is in closed vessel. Therefore the bomb is heated above the boiling point, and the conventional or the molecular weight oven, and it is a commercially. Okay, so this is all about the hydrothermal synthesis. Next time we have to discuss the next soft chemistry route, that is about the solvothermal. Okay, thank you.